So if you want to really get your head around one of the most, well, frankly, one of the most frightening tech disasters ever, you have to go back to 1986, to the Chernobyl nuclear power station.
Yeah, and this isn't just a story about some big explosion. It's really a masterclass in how a flawed machine, combined with some really, really bad human errors, can create a global nightmare.
It's an event that basically changed how the entire world thought about industrial safety.
It really is. The plant itself was in northern Ukraine, right near the border with Belarus. It was a huge part of the Soviet Union's plan for industrial growth, built to power everything.
And right next door, I mean, just 2 miles away, was the city of Pripyat.
Exactly. Pripyat was a purpose-built city. It was designed to house the 50,000 people who worked at the plant, engineers, workers, and all their families.
So a whole city existed just for this power plant.
Completely. And the nearby Pripyat River wasn't just for looks, it was absolutely essential. It provided the enormous amount of water needed to cool the reactors.
Okay, so we have this giant plant, a city that depends on it, and a river keeping it all cool. So for our deep dive today, we're going to break down the 3 big things you need to know: the flawed machine, the terrible mistake, and of course, the massive consequences.
Let's start with that machine. The reactor was a specific Soviet design called the RBMK 1000. It was ambitious, and as it turns out, secretly very dangerous.
Okay, so how did it work? And let's try to keep it simple, because the mechanics here are really the key to why it all went so wrong.
Right. So at its core, it used graphite as something called a moderator.
A moderator, what does that do? Sort of manage the reaction?
Exactly that. It's the material that slows down the neutrons flying around during fission. That makes them more likely to hit other atoms and keep the chain reaction going smoothly. Meanwhile, you have water pumping through tubes to carry all that heat away.
And that hot water turns to steam, drives the turbines, makes electricity. Got it.
Yeah. Now, in most Western designs, water does 2 jobs. It cools the core, but it's also the main moderator.
So if you lose the water, the reaction starts to shut down. It's a built-in safety feature.
Precisely. But in the RBMK, the graphite was the moderator. The water was just for cooling. And that's where you find the fatal flaw, something we call a positive void coefficient.
Okay, that sounds technical. What does it mean?
It means that if the water suddenly boiled away and turned into steam creating a void or a bubble, the graphite moderator suddenly became too good at its job.
Wait, so losing the cooling water didn't slow the reaction down. It sped it up?
It did the exact opposite of what you'd want. Losing the water, which normally absorbs some neutrons, actually made more neutrons available. The reaction instantly accelerated, which created more steam, which made the reaction accelerate even more. It was a vicious, self-perpetuating cycle.
So it was basically designed to destroy itself if the cooling failed. That's terrifying.
And to make it worse, it didn't have that thick concrete containment building you see at most other nuclear plants, the big dome.
Yeah, the one designed to stop radiation leaks if everything goes sideways.
It didn't have one. All it had was a heavy concrete shield on top of the reactor itself, but that was never designed to handle a massive internal explosion.
Which brings us to the moment they took this flawed machine and pushed it way too far. The safety test.
It sounds so ironic, doesn't it? A safety test. On the morning of April 26, 1986, the crew at Reactor 4 was supposed to run a test.
And what were they testing for?
They wanted to see if, during a total power outage, the turbines, as they were spinning down, could generate enough leftover power to keep the cooling pumps running for a minute or so.
Just until the backup diesel generators kicked in.
Exactly. It was meant to bridge that gap, a safety improvement. But the way they did it was just reckless. They started by intentionally lowering the reactor's power.
And that's when things started to go wrong.
Immediately.
Yeah.
Their first huge mistake was disabling several of the automatic safety systems.
They just turned them off.
Switched them off. They thought the safety systems would interfere with the experiment and, they assumed the test would be quick.
So they deliberately removed the safety net. What happened next?
Well, the power level dropped way, way lower than they wanted it to, almost to 0. And that's where the RBMK's instability at low power became a huge immediate threat.
Okay, so the reactor is now in this really volatile state, almost impossible to control.
And to try and save the test, to get the power back up, they made their second massive mistake. They started pulling out almost all of the control rods from the reactor core.
And remind us, the control rods are like the brakes on the system, right?
The absolute brakes. They're made of boron, and they soak up neutrons to slow down or stop the nuclear reaction.
So by pulling them out,
They were essentially flooring the accelerator while having already disconnected the brakes. The reactor was now a time bomb.
it's just a cascade of terrible decisions.
And you have to remember, they were under a lot of pressure to get this test done. It was the end of a shift. But that rush, combined with not really understanding how dangerous the reactor was at low power, it sealed its fate.
So what was the final trigger?
The temperature and pressure started swinging wildly. In a last-ditch effort, they hit the emergency shutdown button, which was supposed to slam all the control rods back in.
But it was too late.
Far too late. Because of a design flaw in the rods themselves, inserting them actually caused a small power spike for a split second before it started to drop, and that split second was all it took.
So the shutdown button actually caused the explosion.
In that specific unstable condition, yes. In a matter of seconds, the power spiked to over 100 times its normal level.
100 times.
The water in the core flashed instantly into superheated steam. The pressure was immense, and that's what caused the first huge steam explosion. It blew the 1,000-ton lid clean off the reactor.
1,000 tons of steel and concrete just thrown into the air.
It destroyed the roof of the building and left the glowing hot reactor core completely exposed to the night sky.
And there was a second explosion.
Moments later, yes, air rushed in and reacted with the superheated core material. That second blast scattered burning chunks of radioactive fuel and graphite all over the site, starting dozens of fires.
And that burning graphite.
It was like a giant radioactive chimney. It burned for days, just pumping tons of radioactive dust and gas high up into the atmosphere.
The first people on the scene were the local firefighters.
They were. They arrived very quickly to fight the fires on the roof and in the surrounding buildings.
And they had no idea what they were walking into.
None at all. They were told it was a simple roof fire. They wore their standard uniforms, no radiation gear. They were walking onto a roof where the radiation levels were just instantly lethal.
I read that the tar on the roof was melting from the heat and it was sticking to their boots.
It was, but they stayed for hours, fighting to keep the fire from spreading to the next reactor, Reactor 3. If that had gone, the disaster would have been, well, orders of magnitude worse.
So they saved millions of lives, essentially.
They did, but most of them suffered from acute radiation syndrome. They were heroes who paid the highest price because no one told them the truth.
And while all of this is happening, in the city of Pripyat, just down the road,
Life is going on as normal for a full 36 hours.
36 hours.
Ugh.
So you have children playing outside, people going about their day, breathing in this invisible poison.
It's heartbreaking to think about. The Soviet government didn't even admit anything was wrong until radiation alarms started going off at a nuclear plant in Sweden, hundreds of miles away.
So when they finally decided to evacuate,
1,200 buses showed up all at once. Residents were told it was temporary. You'll be back in 3 days, they said.
so they only took the bare essentials.
Just documents, a change of clothes. They left pets, photos, everything. And they never came back. That's why Pripyat is a ghost town today, just frozen in that moment.
And that radioactive cloud didn't stay put?
No, the winds carried it almost immediately. It
Yeah.
went into Belarus, Russia. Within days, it was detected all across Europe, from Sweden to the UK.
What were the most dangerous elements in that fallout?
The big ones were iodine-131 and cesium-137. The iodine gets absorbed by the thyroid gland, especially in kids, and can cause cancer. The cesium has a much longer life, about 30 years, and it gets into the soil, into the food chain, through milk and vegetables.
So the first job was to contain the mess at the site itself.
Absolutely, and that's where the liquidators come in. Hundreds of thousands of them, soldiers, miners, engineers, were brought in to clean up the site and build a giant concrete shell over the destroyed reactor.
The sarcophagus.
That's the one. And the radiation was so intense they could only work for incredibly short shifts.
Like minutes or even seconds at a time.
Exactly. Just long enough to run in, dump a shovel of concrete, and run out. It was a monumental effort under the worst conditions imaginable. That first structure used 400,000 cubic yards of concrete and over 7,000 tons of metal.
And that was just a temporary fix, right? It's since been covered by an even bigger structure.
That's right. The new safe confinement. A gigantic arch that was slid over the top to permanently seal the site.
And the long-term health effects for people in the region.
Well, for those closest to the plant, it was acute radiation syndrome, which was often fatal. In the years after, the clearest and most direct consequence has been a huge spike in thyroid cancer, especially in children who drank contaminated milk right after the accident.
This all led to the exclusion zone.
Yep. A strictly controlled area with a 19-mile radius around the plant. You're just not allowed to live there. It's this vast, empty landscape of abandoned towns and villages.
But there's a really strange twist to this story, which is that with all the humans gone,
Nature has come roaring back. It's become a huge accidental wildlife sanctuary. Wolves, deer, wild boar. They're thriving in the abandoned streets of Pripyat. It's a powerful reminder of how quickly nature reclaims a space.
So when you put it all together, what's the lasting legacy here? This changed everything.
It was a brutal wake-up call for the entire world. It led to huge international efforts to tighten up safety rules, improve reactor designs, and make sure something like this could never, ever happen again. The fatal flaws of the RBMK were addressed.
It really proved that a failure in one country can have immediate global consequences.
Absolutely. And today, the site is a place for scientific research and, believe it or not, tourism. People go to see this monument to failure, this reminder of what's at stake.
The accident forced us to realize that with powerful technology, you need absolute vigilance. If you mix a bad design with human error, the cost is just catastrophic.
Chernobyl remains the most serious reminder in history that we must respect the power we harness.
Good luck with your studies.